Hello students, Miss Swanson here, and today we're going to learn all about scientific notation. Now, I like this little picture here. Scientific notation is all about representing really big numbers or really small numbers in a small amount of space on a piece of paper. So we have a fancy looking bird here whose bank account balance, I'm assuming, which is really large, can't fit on a piece of paper, so he has to use scientific notation. So we have one learning goal today. You should be able to convert between standard notation and scientific notation, so both ways back and forth. So let's start off with what scientific notation is. Well, it's written in a form of a, which is a coefficient, times 10 to the power of b. So a is a coefficient between 1 and 9, and often it's a decimal number. B is an exponent, and it's positive for large numbers and it's negative for small numbers. So I said scientific notation is used for large and small numbers, so you know whether you're dealing with a large or small number based on the sign of the exponent. And then the base is always 10, so it's always a times 10 to the power of b. And just a reminder about exponents, if we have something like 10 to the power of 3, that means 10 times itself 3 times. It's not 10 times 3, it's 10 times itself 3 times. So 10 times 10 times 10. If we have an exponent that's negative, it's 0.1 times itself, however many times in the exponent. So if it's 10 to the negative 5, then it's 0.1 times itself 5 times. So let's see how we convert back and forth, this time converting standard notation into scientific notation. So you're going to move the decimal so that only one single non-zero digit is in front of the decimal. And then the number of times the decimal is moved is the exponent that you're going to write. And again, it's positive for large numbers and negative for small numbers. So let's take a look at an example here. So we have 58,000. And if we move our decimal, now if there is no decimal in the number, it's considered to be at the very end. So our decimal will be at the end like that. So we're going to move this decimal so there's one non-zero digit in front of the decimal. So we'll move it 1, 2, 3, 4 times, and that'll give us just a 5 in front of the decimal. So we're going to end up with 5.8 times 10. And we move the decimal 4 times, so 10 to the power of 4. Let's take a look at a small number now. So in this case, we already have a decimal, but we need to move it so that there's one non-zero digit in front of the decimal. So in this case, we're going to move it 1, 2, 3, 4 times. So we'll end up with 2.56 times 10. And we moved it 4 times, and we moved it to make a small number in scientific notation, so it'll be negative 4. So the 4 to represent that we moved it 4 times, and the negative to represent that it was a small number. So let's try converting the other way around, starting in scientific notation and putting it in standard notation. You're going to move the decimal the number of times as what's written in the exponent, and then fill in the zeros. So let's take a look at a large number. We have 6.2 times 10 to the 3. So we're going to write here 6.2, and 10 to the 3, we'll move the decimal 3 times. So 1, 2, 3. And it'll end up right there. And then we fill in the rest with zeros, so there would be a 0 there and a 0 there. So we'd end up with 6,200. Let's try another example, this time with the small number. 3.1 times 10 to the negative 6. So we're going to start off with 3.1, and we move the decimal 6 times. Because we're using a negative 6, we want to make the number a small number, so we move the decimal towards the left. So we're going to move it 1, 2, 3, 4, 5, 6 times. So we put the decimal there. So we're going to fill in the zeros. And since our number can't start with a decimal, we need to have a 0 in front of that decimal. So we'd end up with 0.1, 2, 3, 4, 5 zeros, 3, 1. So that would be our final answer. So our learning goals, can you convert between standard notation and scientific notation? If you can do that, fantastic. If not, please re-watch the video. And if you're still having trouble, come ask me in class tomorrow. Alright, that's all for now. Bye-bye.